Hi, this is part of the review for the msox3034t from Keysight. In this video, I'm going to take a look at a glitch capture. Now, for this application, for this experiment, I've got a Teensy, which is a Cortex M7 controller, Teensy4, which generates requisite glitches. So as you can see, I've programmed the system to right now generate a clock of a much wider interval, time period, and then a smaller glitch right after that. Okay, so in this you can see there's the actual clock signal and there's the glitch. So the glitch is essentially it's a pulse, and I can go right up here. It's the same signal on the Roden Schwartz. So essentially it's this signal is a much less hold on a second. There, great thing about the Roden Schwartz, and there we go. So that's the little runt pulse. Okay, well, it's not a runt pulse, it's that the amplitude is the same, it's just a much smaller, width. Now I'm going to update the same code. I'm gonna update and I'm gonna run this on I'm gonna do a single trigger, and now I've got, after every 2 pulses, after every fourth pulse is now the pulse that we are supposed to capture. Okay, and now I'm gonna set the system to generate now I've reprogrammed the controller, and now it's, well, after every 5,000 or so pulses, it's going to be generating that. So if I go into run, you can see it's now becoming difficult for it to capture. Go back into scale, set it up. There's still that little glitch somewhere, but I can't capture it. Okay, there you can see there's a little bit there because I've set it up to envelope detect. So every time that the pulse kind of comes in, it'll appear, but then again the refresh rate on this Roden Schwartz is relatively less. Let's move to the Keysight. Let's level it off. Okay, on the Keysight, all I need to do is run it, and where's the let's position this. Where's the runt pulse? According to the high refresh rate, you should be able to see it right off the bat, and you can see it kind of appearing and disappearing. The fluctuation is there, but can't really see it, can you? Go up into it, and I'm going to go into zone. I'm going to disable that, please. Zone triggering is disabled. So after every 5,000 or so, it does pop up. I don't know if you can see this or not. The intensity is let me see if I can get the display up. Add persistence to variable persistence. You can see there pops up that little pulsy thing. So yes, it's possible. It's of course the higher refresh rate on the Keysight makes finding that little glitch easier. But can I do a better job with the Roden Schwartz? So go back. Okay, hopefully that'll stay stable. For the Roden Schwartz, I'm gonna scale in. It's pretty much not gonna be able to find that pulse yet. I want to find it, right? So what I'm going to do is I'm going to take the trigger level, I'm going to tweak it. Okay, and go up and down. There we go. It kind of goes up and down. Go in, and I'm trying to find that little runt. Not a runt, actually. It's trying to find that little pulse. There it is, sort of. You can see because of the ringing in the signal, it's basically using that as a trigger level, but there we go. Okay, so if I do this, there we go. Bingo. So yeah, I've got persistence enabled, and that kind of assists with it helps with the detection. But as you can see, it's tweaking those settings and using those the qualities of a pulse of that little glitch. You can technically, capture it using a cheaper scope as well. This is a unique scenario where there's a little bit of ringing, so I kind of trigger on the rising edge right in the beard there. Can't know if you can see this. There we go. There we go. So taking it down a bit. There we go. So it'll pop up in different places, but definitely the waveform, the higher refresh rate on the key site wins hands down. Well, it wins, but can I use a slower scope? I can. I've done a screenshot in the written doc for this review where I've shown that the rodent shorts is able to, once you know the shape of the actual glitch and the timing for it, it becomes easier for you to isolate it and so on and so forth. So does the high refresh rate add value? Definitely. Is it a deal breaker if all the other scopes don't have it? No, it just takes a little bit more ingenuity to kind of come up with a trigger that'll actually help you with. Probably, I've been doing external circuits, add a little bit of extra electronics to the output, filter some stuff out manually, use that as a trigger, and so on and so forth. That's why all scopes have an external trigger input as well. You can use clock recovery to trigger on a clock, so on and so forth. But it is feasible. It is possible. The thing that the other scopes don't do is the go into the triggers. Okay, go into the type, select edge, select pulse width, and this is something that the other scopes just can't do. I mean, select a pulse based on the width is something that they really can't do. In this case, it's going to be a pulse less than 100 nanoseconds. So click here. I want it less than. Click on that E. So 100 and enter, and there we go. So capturing the pulse less than 100 nanoseconds, and then still also qualifying for the triggers. That's a little bit difficult, but that's only feasible because of the high refresh rate of the key site. There's other videos highlighting other features and some problems with the key site as well. But this video was dedicated to understanding. I'm using. Let me go into show you that. There's a little micro that's that little controller is actually generating the signal, and so yeah, it's I know, don't look at the probes, but this is one of the possible scenarios, and yeah, the glitch capture and the high refresh rate is useful. Not a deal breaker, but definitely useful. All right, have a look at the other videos. Let me know in your comments if you want me to try other experiments with the glitch capture, and I will post a video. Thanks for watching. I'll see you in the next vid.